Hello everyone, this is the Pro Motor channel and today we're going to take things apart. This engine right here, this is a Volvo engine taken out of a car like this. The engine model and specs will now appear on the screen. So, not long ago I had a Volvo engine repair on my channel. Well, that engine was simpler. In fact, not just simpler, but probably an older model. This engine here is already more modern. We can see here that we already have a pump and an injector. And we can see that there are 4 valves per cylinder. Also, the main difference is that there's a single head for all 6 cylinders. So it's huge and heavy. I don't know how much it weighs. Probably more than 100 kilograms. Maybe 150 to 200 kilograms. I think something like that here. And we can also see that we have an overhead camshaft here. The camshaft is mounted on the head, so there are no push rods or rockers on this engine. The cam lobes act directly on the intake valve, the cam lobe on the intake valve, and also the cam lobe on the pump and injector. These are the main differences that immediately catch the eye. But now as we go along, we'll take it apart and see what else makes this engine different from the previous Volvo engine. This engine has been on my list for a long time. It's probably been about half a year since the customer made the down payment, and only now was he able to come in for repairs. So he arrived from St. Petersburg. We have the usual task with this engine: disassemble it, check for defects, handle some repairs ourselves, send parts to third-party organizations, order spares, reassemble, install the engine in the car and start it up, likely in the car. Everything is standard. So we removed the engine from the car and I've already washed it. We took it to the car wash and I've cleaned it as much as possible. So I spent several hours here knocking out the dirt, trying to get it out of all the hidden spots. The engine was covered in a thick layer of dirt and dust. Basically, I spent 2 hours cleaning it. Well, basically now it's more or less ready to work on. I have access to the bolts and so on. Before this, of course, it looked much worse. So what we know, this engine has 2,400,000 kilometers on it according to the customer. The customer has been working with this vehicle since 2006, so that's already 18 years. 2,400,000 kilometers. And the engine has never been repaired. Well, now we'll take a look at all of this. We'll see everything now. So I'm really interested to see what has happened to the engine over such a long period and such high mileage. We're going to take everything apart and check it. So I'm starting to disassemble the engine. But first I'll insert some footage that I've already shot. There's not much about the car itself, just how the car looks, the container, and how we remove the container from the frame. I also have footage of how I remove the gearbox and so on. Now I'll show you the clips that I've already recorded, and next I'll get ready to take it apart. I also want to mention that we removed the valve cover on the car. But first of all, there wasn't this loop. We found this loop at the junkyard and bought it. There was no way to hook up the engine. We were already thinking of making some kind of homemade loop for these bolts and hooking the engine to it. So as I already said, we bought this factory made loop, attached the eye to it. In any case, we would have had to remove the valve cover because on this side the chain was attached to 2 bolts like this, and then we hooked the hook onto this chain. Basically the cable was pressing right against the valve cover itself, and since it's plastic it would have been better to remove it so it wouldn't get broken. The engine is big. It's larger in size than, for example, the Mazda 2876. It's a large engine and accordingly heavier. So this is what the valve cover looks like. The valve cover is just gigantic in size. I don't know how clear it is on camera, but for example, if you compare it to my hand, or for comparison, I have an angle bracket that's 25 centimeters. That's just to give you an idea of the scale of the valve cover and really the scale of the engine itself. So what can I say about the engine? We can see the significant deposits inside. On the valve cover, on the here for example, yeah, here For example, how much is on the valve cover itself. Also under the valve cover, we can see it on the camshaft, on the rockers, and so on. In general, everything here is covered with sludge deposits, so what problems did the customer have with the engine? So the main problem is that it's blowing a lot of crankcase gases. On this side, we have a tube coming out and smoke was pouring out of it, thick clouds of smoke. So you could say that's the main problem here. There aren't really any particularly critical issues. This is simply scheduled maintenance for us since we've reached 2,400,000 kilometers. All right, let's begin disassembling. First, let's review the footage I've recorded. Let's go. So once again, I want to draw your attention to one thing. That is, the engine is straight from the factory. Nothing has been done to the engine yet. And we can see that all the wires are painted with the same paint as the engine itself. We can see that, yes, so this is to address those who write to me saying you can't paint over wires, you can't paint over bolts, nuts, and so on. I'm showing you the factory. Everything is done the same way. We can see all the wires, the corrugated tubes, everything is painted with factory paint. The paint has already peeled off the metal and cast iron in some places, but on the corrugated tube the paint is still there in some spots. I'm taking apart the engine, and what do I want to say? So, regarding the previous Volvo engine, I said that everything was done poorly. Everything was done in a way that seemed unplanned and not well thought out. So, has my opinion about Volvo engines changed while working with this engine? No, it hasn't changed. Everything is still done poorly and without proper planning. In some areas it's unclear how to access things or unscrew parts and so on. So there are a lot of things that weren't thought through, a lot of things that you could say were just left to chance. It turned out the way it did. I won't list all these little details right now, but they are there. And my opinion about Volvo engines hasn't changed. Even though I took the most popular engine from Volvo, my opinion hasn't changed. I'll say it again, this is just the beginning. We're going to keep taking things apart and see what else is going on. But after working with this engine for several hours, it's already enough for me to understand that there's no difference. Whether it's that engine or this Volvo engine, it's still Volvo. That says it all. Let me clarify, I'm not an expert, I'm just sharing my personal opinion. Another person might think completely differently, so I'll repeat, I'm just expressing my personal opinion. So I set the timing marks before removing the camshaft. So on the camshaft we have these marks. You can see a movable mark in the middle between two fixed ones. And also on the crankshaft there are marks according to the flywheel.
That's how I set it up.
The mark on the flywheel is at 0 degrees. That's it. My first cylinder is now at top dead center on the compression stroke. In this position, both the camshaft and flywheel marks are aligned. Alright, now I'm going to remove the camshaft. To do this, first I unscrew the rocker arm. Here we have the bolts in groups of 2, and then I unscrew the rest. The camshaft, the remaining bolts, I remove everything. The camshaft, I'll remove the injectors, take off the cylinder head and unscrew the bolt and mounts to the cylinder head. And then we'll turn the engine over, remove the oil pan and so on. I finally removed the cylinder head, and the first thing I can say is the wear is just gigantic. The wear is just huge. So in any case, we'll need a new piston assembly, new piston sleeves. Well, we'll take everything apart now and check. As for the block, It's hard to say right now. For example, I see a defect here on the fourth cylinder, the seat for the sleeve, most likely, and also on the third one. Well, in general, let's not guess, we need to take it apart and then everything will be clear. So, I removed the front cover, got to the timing gear mechanism and wiped them down. Well, I checked if there were any marks on them. There are no marks on the gears themselves. So, it turns out that the marks are set here, as I showed earlier, on the camshaft at top dead center, and on the flywheel it's set according to the mark on the flywheel cover. That means we need to align the crankshaft and the camshaft here. We don't have a fuel pump here. So, all these gears here, they're all intermediate gears. So this is our crankshaft, the crankshaft gear. This is our intermediate oil pump gear. This is the oil pump drive. This is an intermediate gear. This is an intermediate gear. And this is an intermediate gear. And from them, the drive goes here to the fuel pump, the low pressure pump, and here to the power steering pump. But actually it's the other way around. Here I think is the power steering pump, here is the fuel pump, and here is the water pump. And in this spot I think there's nothing else. This is an intermediate. And here we have the camshaft drive. Next I'm removing the oil pump, and then I'm taking off all these intermediate gears. Here, after I remove the oil pump, I'll take off this protection, this additional plate. As you can see, I removed the oil pan. One bolt was unscrewed like this, so it didn't fall out because of the oil pan. It was resting against the pan. As you can see, all the bolts are in place, except for one. So, I'm removing the pump, taking off this plate, and then I'll move the engine. Next I'll remove this intermediate plate, move the engine a bit to this side so the cover hangs down, and then I'll take off the cover. All that's left is to remove the pistons and sleeves. I don't know, with this much wear I probably won't be able to get the pistons out. The wear is very bad here, I'm not sure why. 7, 8, maybe 9 tenths, definitely over half a millimeter. The flywheel housing is also covered in oil. Our oil seal is leaking badly, with a stream forming a puddle here. The oil seal clearly needs replacing. We can also see the engine is covered in greasy deposits, showing oil was burning and leaking badly, as I said. So, it turns out that these exhaust gases were leaking into the engine crankcase, and here they mixed with the oil. That means we had combustion products from the combustion chamber, as well as combustion products from the oil itself and so on. I'm not sure. I'll definitely struggle to clean this engine. It's usually hard to wash all of this away. I don't know, you have to use diesel fuel and all sorts of things to clean it. I have a feeling that cleaning this engine is going to be a real hassle. More than enough. So, I've been taking this engine apart for 3 days now. Usually you can take any engine apart in a single day. Well, that's if you're not filming, without any distractions. Usually it takes me about 2 days to take an engine apart, not full days though. Because while I'm moving the camera around, setting things up, filming and so on, it takes extra time. So with this engine, it's already my 3rd day working on it. Well, so the 3rd day, I began at midday on the 1st day, and on the 2nd day I worked nearly all day from morning to evening. I got pretty distracted and had extra work, so now it's the 3rd morning. Well, I think by around 3 o'clock I'll have it all sorted out, and I'll make a complete list of everything I need to buy. So, well, I guess later I'll mention some interesting things about this engine. For example, the rocker arm shaft really surprised me. I was an agent. Well, that's all for now. We dropped 2 bottles. It's made with a margin, an enormous safety margin. Well, also, for example, we can see that the camshaft also uses bearings. Not bushings, but bearings. So, this part splits in half, and we just replace the bearings. Put everything back in place. For example, on the camshaft, I think everything will remain as it is. Of course, I'll clean it and take another look, but for now, visually, I don't see any major problems with it. I'll clean it and take measurements. It's possible that new bearings will be purchased, and as for the rollers, probably everything will stay as it is, because everything here is in perfect condition. So basically the bearings are still in quite satisfactory condition. Let's put it that way. Well, the bearing in the cap is definitely in better condition than the one in the connecting rod. The one in the connecting rod, of course, will have more wear, but this one also has some wear. If we look here, it means the bearings are still original Volvo ones. I don't see the manufacturing date. This bearing is probably original from the factory. I'll repeat, the customer said the mileage is almost 2.5 million kilometers and this engine hasn't been repaired yet. Given that the customer has been working with this vehicle since 2006 EEL. That means the person has been using this vehicle for 18 years and the engine hasn't been repaired yet. So, we see another interesting thing here. The piston is composite, meaning the skirt of the piston is separate from the piston crown. That's how it is. And all of this is connected by the piston pin. Well, I've made engines like this before, but specifically on the channel, this is the first time we've come across pistons like these. Like this. All of this is connected by a piston pin. The skirt is installed separately and the piston crown is installed separately, and even as far as I can see the materials are different. This is aluminum and this, the crown itself, is possibly even cast iron. Yes, well, of course, the engine is just in perfect condition. With this kind of mileage, considering that the mileage is almost 2.5 million kilometers, and the overall condition of the engine, I just don't know, it's amazing. The margin of strength on it is simply colossal. Well, the pistons, the skirt of the piston, seem to still be in good condition, but the piston rings themselves, the groove, you can see that it's worn out. That is, the ring is already loose. We'll have new pistons, so the sleeves, bottoms and pistons all need to be replaced. Well, it wouldn't make sense to replace all of this and leave just the skirt if it's even possible to get it separately. Most likely this piston is sold as a complete assembly, not in parts. So I think we'll have a brand new piston assembly anyway. Well, we'll take a look at the connecting rod bushings too. Basically they seem to be okay as well. No, well, there is some play, yes. The connecting rod bushings will need to be replaced. The connecting rods definitely need to be checked, because with this kind of mileage you can already see the imprint from the bearing. So we'll check the connecting rods on the machine, and if everything is fine, then we'll just replace the connecting rod bushing. As for the block, I don't know yet. Let's not guess for now. We need to take it apart and see what kind of machine work we'll need to do on the block itself. So, well, the main bearings are definitely in worse condition, and we can also see that the bearing here isn't sitting properly in its seat. Also, we might have some issues with the block, but we'll take everything apart now, clean it, take measurements, and then we'll know what we need to do with the block. Well, we can also see the Volvo logo on the bearings, so the bearings are still original. For watching. So my engine is disassembled. Let's sum up. So as I already said, the engine is in very good condition, especially considering it has 2.5 million kilometers on it. You could say the engine is just in excellent condition. What work do we have ahead of us? Well, first, the block doesn't need to be cleaned. You can see the deposits here, as I showed. The block doesn't need to be cleaned. Check the seat for the sleeves and check the seat for the main bearings. But still, I think that the bearings will need to machine the seats for the main bearings, because first of all, the mileage is already very high, and secondly, you can visually see the bearing right here. Right here, it had a bit of play like this. So in any case, there's wear in this spot. And also by the imprint of the main cap right here, we can see a step. Currently, the block is dirty. I'll clean it up and take measurements, but I believe it will still need machining for the main bearing seats. That's the minimum. Next, the pistons. We'll have new ones. By the way, I want to show you the cylinder liners and what condition they're in. Honestly, I've never seen liners and a block in such perfect condition after this kind of mileage. So this is probably the best engine in terms of the water jacket that I've ever seen in all my experience. This shows that the engine was running on good antifreeze. Not once in its entire operation did this engine have water in the cooling system, and so on. So we can see the condition of everything. Well, here the wear, as I said, is about 0.5 millimeter. You can even see this step on camera. All sleeves, connecting rod and main bearings need replacement. I believe the bearings will be standard size, because as far as I could see, there are no issues with the crankshaft. It's just in perfect condition. I don't think there's even a 200 undersize here. The measurements won't even show a 200 undersize. There aren't even any scratches. If before we had a Volvo crankshaft, you could visually see scratches on it, and there was about 400 or 500 of wear. But with this crankshaft there are no such issues. I'll also be removing these plugs, cleaning the channels, blowing them out and washing them. The fuel equipment will go for inspection first, and maybe later we'll replace the nozzles. We'll have new pistons in the set and new rings as well. Next, the turbocharger will go for inspection first, and then maybe it will be repaired. As for the cylinder head, we'll disassemble it, inspect it, and check for defects. I think we'll replace the valves, guides, and seats. We won't be able to send it to the surface grinder because its size doesn't allow us to fit it into the machine. The head will likely stay the same, I'll just clean it. Well, basically, there were no problems with the gasket, meaning there were no leaks anywhere. The coolant didn't go outside or inside, so I think there won't be any problems. We'll just clean it, wipe the valves, replace the valve stem seals, and install a new gasket. And I think everything will be fine. So, the pump, the water pump, will either be new, or we'll install a repair kit. Honestly, I don't know if it's possible to install a repair kit here. I haven't worked on pumps like this before, but we'll figure it out as we go. So, we also need to clean the gears and check the bushings. Each gear has a bushing. Also, check the shaft. Well, for now, everything looks fine visually. But, as I've said many times before, you need to clean everything first. Only when the part is clean should you inspect it for defects. Camshaft-wise, I don't expect any issues. I checked it visually and everything looks fine. I'll clean it and also measure it. We'll be replacing the bearings as I already showed. Here we don't have bushings, but rather we have bearings. By the way, it's a very interesting solution. I haven't seen anything like this on any engine I've worked with in my practice. I've never seen a camshaft mounted specifically on bearings. So, I don't think there will be any issues with the rocker arms either. I'll clean everything, blow it out, and put it all back in place. I'll take apart the oil pump and have a look, especially since the housing here is aluminum, which isn't very good. So we'll take another look at the oil pump. And as for this pile of parts, we'll wash everything and check everything. For the front cover, we'll need to buy a repair kit, or rather, a kit specifically for installing this cover. It fits onto the block without any guides, and that is because of the position of this cover. The gap in the gears is adjusted. So if you move it, let's say, to one side, then one of the intermediate gears, for example, will get pinched and the other will have a lot of play. So this is a very important point. We'll try to find the factory guides specifically for installing this cover. Well, if it doesn't work out, then I'll have to think of something. Maybe I'll have to make some homemade ones or something like that. But when assembling, you definitely need to pay attention to this point. And another feature of Volvo engines, that all these covers are installed without a gasket, just with sealant. When I worked on that engine, it was exactly the same. The intermediate plate was sealed with sealant. Then this cover with sealant and the rear housing also with sealant. But, for example, the valve cover and the oil pan are installed with a gasket. So we'll also disassemble the compressor and check it. Maybe it will need minimal repairs, like replacing the valves and piston rings, just like we did with the previous compressor. Well, maybe there will be a more major repair, or maybe we'll even need a completely new compressor. We'll get to that later as well. We'll take a look at everything. As for the electrical equipment, we've got the starter, the generator, the wiring, most likely. All of that will go in for repairs, or at the very least for inspection. And then, based on the results of the inspection, we'll decide what to do with it. I also want to say a few words about the engine itself. The engine is really interesting, especially since it's something different to work on. I'm actually curious to see its design myself. There are a lot of design solutions here that I haven't come across in my experience before. That's what makes this engine interesting. Also, the engine is very reliable. We've put a lot of miles on it, and you can see what great condition it's in. And again, the engine itself, I wouldn't say this engine is particularly complicated, but you could say it's a bit inconvenient. So, everything is made in a way that's a bit poorly thought out and so on. So, the engine is good, the engine is reliable, the engine isn't particularly complicated, but the engine is inconvenient. That's the conclusion I came to for myself. That's just my personal opinion. Alright, I'm starting the assembly. The engine block was at the machine shop. The main bearing seats were machined, but basically we didn't touch the cylinder head mating surfaces or the cylinder liner seats. Everything's fine there. So about the main bearing seats, said we removed the engine just in time because the bearings were about to spin. And if that had happened, the block would have been a total loss for sure. The block arrived to me yesterday, and now my task is to work on the block some more and get it ready. Here we can still see some metal shavings, this amount right here. I need to blow out all the shavings, then blow through and clean all the channels, open up the plugs wherever necessary, then install the oil jets back in place. After that, we'll start the assembly. That means installing the crankshaft. The camshaft in this engine is installed in the cylinder head, so there's not much work to do with the block itself. But what I mean is that there's no need to change the bushings, install the lifters, camshaft and so on. So, we install the crankshaft, put in new sleeves, the piston assembly will be new, and then we install the pistons. Everything happens step by step. All the parts have already been purchased. The engine was disassembled about 3 or 4 weeks ago, so almost a month ago. And as I remember, the engine here is very dirty inside. I mean, probably the dirtiest engine I've ever worked on in my entire practice. I don't know what day it is. I'm already working on cleaning it, washing it by all available means, using diesel fuel, chemicals, a pressure washer and a jet type washer. I'm trying everything to clean this up. I'm exhausted, and that's just how it is now. I've spent a lot of time washing it, but I'm telling you, I've never had anything like this happen with any other engine before. Well, for example, this is what it looks like after using chemicals on the pressure washer. So we can't see it here. I still need to remove some old gaskets, or rather the old sealant, clean up some areas, run a tap through some threads and so on. So there's still work to do. We'll be taking care of all that as we go. That's it. That's the scope of work. Let's get started. So, right at the beginning of the video, I'll talk about how YouTube works. Everyone knows that it's been running slowly for quite a while now. Unclear, some use a VPN, others use different programs. I also suggest installing a VPN. It solves everything. Well, at least at home I installed a VPN on my Android television box and watch YouTube without any problems. And also, for those who can't watch on YouTube, I'll be uploading my videos to YouTube and Dizen as well. And I also plan to create a VK video channel. Well, I don't know how well it will work out or if I'll have enough time for it. Links to all my channels are in the description below this video. So next I'll be installing the crankshaft. I've prepared and polished the crankshaft. Well, first I washed it in diesel fuel because I already said this is the dirtiest engine I've ever seen. There was a lot of greasy, sooty, burnt residue. I washed it with diesel fuel, then cleaned it using a special degreaser. Well, this stuff basically dissolves oil deposits really well. I cleaned out all the channels, washed off the diesel and blew it out. So I also unscrewed the plug. You can see we have these kinds of plugs here. This is how it screws in. And inside we have the oil drilling channel. So, as I mentioned in the previous video about the Volvo engine, about repairing the Volvo engine, there was a lot of buildup under this plug. It was a kind of compressed, black, dry dirt. So I tried to pick it out, but it wouldn't come out. So I had to drill it out, basically turning it into shavings, so to speak, and then blow it out. I polished and measured the crankshaft. It's just slightly under, literally by 1 or 2 hundredths, so you could say it's in perfect condition. After polishing, I brought it to the table and blew it off again. Now I'm going to close these plugs, put them on thread locker, and basically that's it. Next we unpack the bearings, unpack the thrust washers, and then install the crankshaft. And we'll also take a look at how our oil channels look right now. This is how we shine a light into the channel that goes to the main journal, and we can see the channel is absolutely clean. Well, that is, I've already checked all of them, blown them out and cleaned them with a thin metal brush attachment on a drill. I've degreased everything here. Everything is now ready for assembly. The crankshaft is tightened. We tighten it to 160 to 170 Newton meters and then turn it another 120 degrees, plus or minus 5 degrees. The crankshaft is fully installed and tightened. Basically, the counterweight here is non-removable. So all plugs are secured with thread locker. The crankshaft is installed. Next, I'm unpacking the pistons and sleeves. Then we'll install the pistons onto the connecting rods, and then the pistons with the rods into the block. So as we can see, this one will be our lightest piston, 5,400, well, let's say 5,405. And it turns out this one is our heaviest piston, 5,443. So it turns out to be 33 grams plus another 5 grams, 38 grams. The maximum difference in piston weight we have is 38 grams. Well, we can see that this piston, as I already mentioned, has a design where the skirt is separate from the piston crown. The piston crown itself is made of cast iron. That's why it has such a weight, such a heavy weight. Well, considering that, for example, on Mercedes pistons, the weight is about 3 kilograms, and there we have a tolerance of up to 100 grams. If here the piston weight is 5 kilograms, then the tolerance here is a bit higher, more than 100 grams. Well, let's focus on the difference in piston weight of 100 grams. Here we have 38 grams, so basically that's within the normal range. Here is more, and so I installed the pistons on the connecting rods. I also checked the piston ring and gap and also installed new bearings. The connecting rod bearings, just like the main bearings, are from the KS company, Schmidt. I've already installed the sleeves in the block without seals for now and measured how much they protrude above the cylinder block. Here we also have a somewhat interesting sleeve design. Well, I don't know how well you can see it on camera. Basically, this spot here has a sort of spherical profile, and so the very top of this profile is the very top of this sphere. It should rise above the level of the block by 1800s. So I took measurements on all the sleeves, and the protrusion of all the sleeves is exactly those same 1800s. So everything is good here too. Well, we didn't do anything with the block in this area, meaning they didn't do anything with the cylinder head mating surface either. They didn't modify the seats for the sleeves, and the old sleeves also didn't have any adjustment rings, so we just installed new ones instead of the old sleeves without any changes. Alright, so now I'm taking out the sleeves, unpacking the sealing rings that came with the piston kit, unpacking the rings, installing them, and then installing the sleeves into the block. I also plan to install the pistons in place today. So as we can see, we have 4 rings, 3 thick ones and 1 thin one. Out of these 3 thick rings, one of them is a different color, kind of purple. This ring is installed nearer the crankshaft, making it the first one for us. So in this way, the very first one we install is the purple ring, then the two black ones and the thin one goes on top. When I assembled the last Volvo engine, I used sealant. I'm unsure here, so I'll check and might add a thin layer. So I installed the sleeves and I also put the upper gasket on with sealant, well, because the engine block is already pretty old and there are still some defects in the seating area for the gasket. So I put it on with sealant, tightened it like this, and I want to show you. In the tightened state we see block 0, so block 0, well, it goes up to about 0.18 millimeters, then further on block 0, it reaches up to 0.18 millimeters. 0, well, here it's about 17 or 16. Let me remind you, it should be somewhere between 14 and 2. 0. To be continued. We also see 18. That's all. So I installed the sleeves yesterday, a night has passed. Now I'll try to unscrew each sleeve one by one. I'll remove these clamps, insert the piston, and then probably put the clamps back in place, because I still have a lot of work to do with the engine. I mean, there's still a lot to do before I install the head. So I'll keep the sleeves clamped in a secured position. So I just want to briefly explain why the process of installing this particular piston took so long. Basically, the oil tubes, or rather the oil nozzle, when you insert the connecting rod, part of the rod hits the counterweight and part of the rod hits this tube. So it feels like the oil nozzle should be installed only after the connecting rods with pistons are already in place. Only then should the oil tubes be installed. Well, I don't know, basically I had to turn the connecting rod a bit like this, rotate it, insert the crankshaft, and then proceed. Anyway, I don't know. I'll try on the next one. It should be easier here because there are no counterweights. So, the marks on the bolts are from when the connecting rods were at the machine shop. The machinists made those marks. I'll wipe them off with solvent now and put my own marks. Alright, so I'm continuing the assembly, and now I'm working on the timing mechanism. I'm figuring it out. The system here is actually pretty interesting. I'll explain briefly. So here we have the crankshaft, and 2 intermediate gears are installed. Or actually you could say 3. These 3 gears are all intermediate. And from them, the drive goes to the equipment here, and over there we have the camshaft drive. So, what's the peculiarity? This cover in relation to the block isn't centered in any way, meaning there are no guides, so it can move around like this. But these 2 gears in relation to this cover are centered, meaning you can't move them. So you need to center this cover in such a way that there's a thermal gap in these gears. About 1/10 of a millimeter like this. I looked up how it's done on the internet and made 2 of these. You could say they're jigs or guides. Basically, there are factory-made guides like this, but here's how their system works. So, an additional cover is attached to this intermediate plate. This cover right here. And the cover itself is attached to the plate using guides. These guides have a 17.8 diameter. And so, when you remove this cover, you need to screw into these spots. Basically, there are 2 little barrels, the same kind of guides, and they're just held in place with a bolt. Temporary guides are installed, and some work is done on the block, like removing this cover and disassembling the timing mechanism. But these guides are temporary. You can't remove them. They have to stay installed on the block. And only after this intermediate plate is installed during assembly, and only after we've tightened all the bolts securing this plate, afterward, you can unscrew and remove the temporary guides. I looked all this up in the literature and found a number that should correspond to these factory guides. Search for them in stock, but they are nowhere to be found. I also looked online to see what others are doing, including homemade solutions and various methods. That's it. So basically I went the same way. Machined 2 bolts like this, screwed them in, installed this cover, for now without any sealant. It's installed without a gasket, just with sealant. I tightened this cover, fastened it, all these gears as well. I tightened them too, just to check and see how everything will fit together. So as we can see here we have a gap of about 1/10, and here the gap is about the same. But this gear here, it turns out, doesn't get centered in relation to this plate. So it moves around like this. That's the kind of plate it has. There you go. And it needs to be tightened only after the cylinder head is installed, after the camshaft is installed, and you also need to maintain the proper clearance. Here 1/10, here 1/10. Well, as an option you can just insert a feeler gauge here, and with the gauges in place tighten these bolts. Also, while I'm working on all this, I came to the conclusion that, well, I've heard from several sources that you shouldn't grind these heads on a surface grinder. That is, the machinist told me that you shouldn't grind them, because then you won't be able to adjust the clearance. Well, I've also heard from other sources that you shouldn't grind this head. So, I haven't gotten to the point yet where I'll be installing it and checking, adjusting the clearance. But from what I can see, with the plate we have here, these are the intermediate gears. So, for example, setting the clearance to something like 0.2 or 0.3 millimeters doesn't seem like a problem at all to me. Well, these are just my preliminary thoughts for now. When we get to the point where we install the camshaft, I'll understand it all more precisely for myself, whether it's possible to adjust within such ranges as, say, 0.3, 0.4, 0.5 millimeters, or not. But for now, I stick to the opinion that adjustment is quite possible. Why not? We have quite a lot of leeway when it comes to mounting this gear. Well, I also want to mention that it's a very interesting system. There's a shaft inside. Oil is supplied to the shaft under pressure, and each shaft has its own channel. From the shaft, oil is supplied under pressure to the gear itself through a bushing, and all 3 gears get oil this way. And also, right here we have an oil nozzle installed, which is also an oil channel, and it has a drilling for each gear. It's a very well designed, reliable timing mechanism on this engine. So what am I going to do now? Now I'm unscrewing all these gears, removing this intermediate plate. Well, unscrewing these guides, lubricating everything, well, degreasing it again, applying sealant. I have a good sealant. I've been using it exclusively lately and I really like it. So I'm applying the sealant. And then I install this plate, tighten it, put these two gears back in place and tighten them as well. For this one, I just set it approximately in the middle position for now and tighten it just a little bit, barely at all. Well, because, as I said, we'll adjust it later. I'll tighten it, install the oil pump next. Move on to the cover. Flywheel, closing the oil pan. And finally, install the cylinder head. I'm not sure when that will be, but I think we'll reach the cylinder head in about 2 days. It seems like there's not much work here, but since all of this is still unfamiliar to me, I have to figure everything out, think it through first, understand it, and only then start assembling. That's how things are for us. We're continuing engine assembly. So as we can see, here's the oil channel. It comes out of the block as a main line and then goes to one of the shafts. Here we have the mounting for this gear shaft, 6 bolts around it. The channel goes to the second shaft. We also see a 6-bolt mounting, and it also goes to the third shaft for the gear mounting. So in this spot we have the oil nozzle that I showed earlier. So oil also goes here to the nozzle. Now we'll apply sealant right here around the perimeter, and also put a thin layer of sealant along the oil channel. That's it. So I'll degrease it and apply the sealant. Apparently there's a small dent here that must have formed when the block was being transported. Now I need to carefully smooth it out with a small file. So I installed the gears, tightened the bolts, use thread locker, and just slightly tightened this one to adjust it a bit, as I mentioned. I also installed the oil nozzle that lubricates these gears. Next, I'm going to unscrew these homemade guides of mine, and then I was going to install the oil pump. So about the oil pump, I took it apart to check its condition. So we're keeping the old pump. I'm going to assemble it now, grease the gears with assembly paste. And I also removed the intermediate gear. And there's this kind of wear on the bushing itself, and the shaft itself also has these kinds of grooves. So on the previous Volvo engine I worked on, I also had to replace this gear. I think we replaced the bushing and the shaft there, and it turns out it's the same with this engine. We can see that the lubricant goes through this hole directly from the oil pump. The lubricant enters this hole and then it gets in here onto the shaft, and then it gets onto the bushing itself. So it turns out that the lubricant goes directly from the pump. It doesn't go through the filter, meaning the oil is unfiltered. If something gets in there, scratches appear right away. This is the condition of the gear, and it's exactly along the channel where the oil passage is. I've ordered a new gear and shaft. They'll be here in a couple of days. Well, basically, I still have some time for now. I've got things to do in the meantime. Let's wait. So, I'll assemble the pump now, install this cover, install the intake, and then we'll wait for the gear. Alright, so I installed the cover and tightened it. It just goes on with sealant, no gasket. So, we see the cover without the oil seal. The oil seal is this large, it's 180 by 205. As we recall, I also struggled to install the oil seal during the last Volvo engine assembly. Well, because whether they come in a gasket set or separately, they come without a guide tool. That is, as some of you may know, there should be a plastic guide tool that comes with the oil seal, so you can easily put it on and it doesn't bend like this. For Volvo, regardless of how many we've purchased, and right now we have an Erling gasket set. It comes with an Erling oil seal, but it also doesn't have the guide tool. So what did I decide to do? I decided to install the cover first, and now, just like this, use my hands to fit the oil seal in, and then tap it in with the guide tools. Basically, this is a workable option. I sometimes replace oil seals on a Mercedes right on site, such as in the pit or on the engine. That's it. Just like that. I put the spring in place and I know for sure that the spring went in and didn't bend. And now I'll carefully seat it all the way around, and that's it. Alright, so I installed the cover and the seal. Basically, it's a good working option. It's much easier to install than last time when I struggled and installed it without a guide. That's it. The cover's tightened, all bolts are secure, and the sensor bolt is in. So, next I'll be installing the flywheel. The flywheel clutch cover and disc are all the old ones. I cleaned them, installed a new bearing, and cleaned and blew out the disc to prepare it. I also cleaned the clutch cover, blew it out, and got rid of dust and dirt. I also prepared the bolts and the flywheel mounting. Alright, so I installed the clutch, tightened it, and put all the studs in place, because when I removed the gearbox, the nuts came off together with the studs. So now I unscrewed the nut from each stud, it was rusted. So I cleaned the threads on the studs, cleaned the threads on the nuts, screwed in all the studs, and put the nuts back in place. Everything is now ready to install the gearbox. Ideally, I should close the oil pan now, but I don't think I have the gear for the oil pump or the intermediate gear. I put the cover on now to check which bolts I have. So, for now, I just temporarily put it in place. So, we're waiting for the gear. The gear will probably only arrive in 2 days. I have 2 days to work on something else before installing the gear when it arrives. I'll quickly install the hub on the crankshaft, close this cover, and then just need to close the oil pan. Well, there are still some little things left. So what do I want to do now? Now I want to turn the engine like this under the hoist and install the cylinder head. So the cylinder head is ready. The cylinder head was repaired. I didn't do the cylinder head myself. The head was sent to an outside company. In general, we were considering whether to grind it on a surface grinding machine or not. We can see there are these pits here, corrosion. So we decided not to grind it and to leave everything as it is. These were the works done on the cylinder head. The guide bushings were replaced and all 12 seats were replaced. The valves are still the old ones. I would still recommend replacing at least the exhaust valves because there is wear on the stem. Well, in general, the customer gave it to an outside organization and they did everything there. They already sent me the finished cylinder head. So now I cleaned it again, I degreased it, blew it out with compressed air, and basically that's it. I checked everything. Now I'm taking out the gasket, I'm hanging the cylinder head on the hoist, so I need to hook it from that side. Alright, so I've prepared everything for installing the cylinder head. I turned the engine, like I said, under the hoist. I installed the guide pins. Now I'll remove these clamps that are holding the sleeves. I'll blow everything out here, wipe it with a cloth, and then we'll start installing. The cylinder head is already prepped. I also blew it out several times already and secured it like this. I tightened the bolts through a large washer onto the chain. So I also prepared the bolts, washed them, cleaned them, blew them out and measured them. The gasket we have is from the Airlink set. So in the set we have an insert. For the tightening torque we use 60 Newton meters, then go over it again with 60. So the gasket is solid and the head is large. We start from the middle. When we get to the outer bolts, the middle will loosen a bit again. So we'll need to tighten it to 60 once more. The middle bolts should be tightened a bit more. They'll give slightly and can be tightened more. Then we tighten it with one 90-degree turn and then a second 90-degree turn. That's it. So this is our tightening sequence. So I've installed the cylinder head and tightened it. Next, I'll work on the injectors. The injectors were serviced by the fuel specialists. So this is what they look like. What's my task now? To replace the seals. As you can see, we have 6 of these packets in the kit. Each one has a full set of seals for an injector. I'll replace the seals and then we'll install the injectors. Here I already have the clamps, the vice parts with bolts prepared, and also the injector. This is where the ball goes in. Here's the ball. This is what it looks like. So in this way, the plunger, let's say, first the ball is inserted, then this plunger presses against the ball, and this plunger is pressed by the adjustment screw. So I rejected these 3 plungers. Well, we can see here the kind of wear it has. Maybe there's a problem with oil supply, or it's just wear over time. Here's the first and second one. And the third one, well, for comparison, this is what a good lifter looks like, and this is what a worn one looks like. So it turns out we ordered 3 of these Bosch lifters. As you can see, it comes with a ball included. And also the matching parts, the adjustment screw, which is installed in the rocker arm itself. We'll have 3 new ones of those as well. So now I'm installing the injectors, and then I'll move on to installing the rocker arms. Well, actually all these bridges on the valves. Here we also have these, what should I call them, barrels. It goes onto the adjustment screw, and then this barrel presses against the rocker arm. I assemble it, the rocker arm, install it, the rocker arm shaft, and then continue with the installation. Now the camshaft, we're keeping the old camshaft. The bearings will be replaced as well as the camshaft seats. I already have all of them on the shelf, cleaned and washed. So right now I'm working on the top part with the rocker arms and injectors. And then I still need to assemble the compressor, definitely today. Also, I need to replace the pump and install a new water pump. Also, I still have some things that haven't been cleaned yet. There's the intake manifold over there. It's not cleaned. I'll also be replacing the hydraulic clutch. There's still a lot of work to do. I'll finish all this now and then get back to cleaning. I'll be cleaning until the end of the day, until the evening. Alright, that's our workload. Let's go. So, I installed the injectors and tightened them. I installed the bridges on the valves. So, a bridge with a disc is installed on the intake valve. And this kind of bridge with plates is installed on the exhaust valve. So, later on, we might still have to adjust these screws, but we'll get to the adjustment part. Next, I'll be installing the camshaft. We're keeping the old camshaft. I washed it, blew it out, inspected it, and it's in excellent condition. So, we see no issues with the camshaft. There are a lot of marks here. I'll explain later what they're all for. It turns out that each valve is adjusted according to its own mark. Well, actually, the camshaft system here is quite complex. So the camshaft has its own main bearings. This part here is flipped towards the cylinder head, and this ends up being the cover. And also, these saddles are designed for inserts. Here we have a set of standard inserts. Now we're going to take them out and install them. We can also see how many bolts there are here. Some bolts are long, some are short, and some bolts are screwed directly into the saddle itself. Here we can see there's threading. Some bolts go all the way through the saddle. The rocker arm shaft is mounted on these guides and passes through them. It's not ready yet. I still need to replace the adjustment screws and do some more work on it. There are also these studs here. A stud, and on the other side again there's a thread. These studs are attached, I think, to this side of the head, like this, and the valve cover is attached to this stud, and these studs also hold things in place. The camshaft itself, I think, is on this side, and then something else is screwed onto them as well. The camshaft cover is attached, indicating this engine's camshaft system is highly advanced and complex. We also have these plates here. They are attached along with the rocker arm shaft and are installed after the rocker arm shaft. So I've laid everything out on the table. Now we'll figure out what goes where, in what order, and so on. Well, I understand that if I only worked with these engines, it would already be automatic for me. But since this is my first engine of this kind, things aren't that simple and clear for me yet. Well, it's all minor stuff, we'll figure it out now. Well, of course, each cap is marked, meaning the bed itself and the cap itself, so you really can't mix them up, and accordingly it can only be installed in one position thanks to the guides. So you can't install it like this either, it can only be installed like this. So, as we can see, there are no oil supply holes in the insert itself. Here we have an oil channel in the cover itself. And it turns out there's a notch on the insert, so the oil gets in exactly through this notch. And of course, this notch is present on every insert, so it doesn't matter which insert goes where. It's just that the first insert comes with thrust rings, the longitudinal thrust ring. So, only the first main journal has a different insert. All the others are the same. For now, I've just loosely installed it. Here I have two bearing caps bolted to the block, and here I've loosely installed two bolts. Now I'm going to remove that big intermediate gear, set the timing marks. I've roughly lined up the mark here as it should be, but first I need to install the front cover, and then we'll check the mark, align it with the flywheel. Basically, the timing marks are set here. The flywheel is set to 0, and the camshaft is also set to, let's say, 0. The top gear is the nasty one, and that's it. All the other gears are installed arbitrarily. So I've installed the camshaft and tightened it, for now only with the lower bolts. It will be fastened together with the rocker arm shaft, so I've tightened it and already pre-adjusted the gear. Well, that's it for now. Later, when I have the rocker arm shaft installed and tightened and the valves adjusted, I'll check the clearance adjustment again. And then after that I'll start unscrewing these bolts. I'll apply thread locker and tighten them in pairs. I've also prepared and cleaned the rocker arm shaft. This is the dirtiest engine I've worked on. I don't know what these deposits, I've never seen anything like them before. I cleaned and blew it out multiple times. So I distributed them 3 rocker arms each. I used the old injector seals just to hold things together, so everything is grouped. I've already installed these discs, applied assembly paste there, installed and snapped them in place, so they've already been replaced. 3 adjustment screws that go on the drive, basically the injector that pushes for us. Let me show you how it looks and got worn out. So this is how it turns out. Here is the cylinder. This is our 6th, 4th and 3rd. We have new adjustment screws installed. And accordingly, I also mark the 6th, 4th and 3rd on the injectors. I'm going to install new push rods here. Now I'm installing these push rods on the injectors, then I'll install the rocker arm shaft. Now, let's start with the adjustment. The intake valve is adjusted. The injector preload is adjusted. The exhaust valve is adjusted. The exhaust valve, we also have a hydraulic push rod for the engine brake here. I'll explain all the details now, but before we install the rocker arms, we need to adjust these bridges, that is, all the adjustment screws. We loosened, or rather, unscrewed the lock nut, screwed the adjustment screw, and basically, this way we tighten this bridge all the way, screw in the bolt until both valves make contact, and after they touch, we turn it just one more flat and lock it with the lock nut. We do this for all of them. But this is for us. Over was floating, connected, and we'll start adjusting the intake valves. Basically, it's clear. We can start loosening the lock nut. We adjusted the bridges, installed the plates, scrapers and cam, and are now adjusting the intake valve. Everything is clear. Bring it up with the screw, lock the gap, and do the same for the injectors. Loosen it as much as possible, make contact, and then turn it for tension 180 degrees. You can do 180 or 240, but as I understand it, 180 is enough. Maybe a bit more, like 190. As for adjusting the exhaust valve, it's a bit more complicated. Here, everything is adjusted with these plates. You can see the size on the plates. 200, for example, means 2 millimeters. Here, for instance, 215 means 2 millimeters and 15 hundredths. So the size is in hundredths, 2 millimeters, 15 hundredths. I don't know. I'll see how it goes. Once everything is installed in place, I'll adjust, record, and check. I'll swap some plates around, or we'll order new plates of a different size. So, basically, we're going to work on all of this right now. So we're swapping the rockers, and it reminded me the neck, real energy. I don't know why all of a sudden. So I swapped the rockers. They were installed incorrectly, so I'm adjusting them again. So I'm working on the adjustment. So I've already set it to V2 here, which means I need to adjust the exhaust valve on the second cylinder. So I took the measurements. My 2.6 gauge fits in, but the standard is that the 1.6 gauge should fit. We can see this kind of gap. So what do I need to do? Here I need to use a shim that's 1 millimeter thicker. For example, this valve has 0.2 mm, but I need 1.6 mm, so I need to add 0.2 mm to the shim. For the one with 2.05 mm, I need to make the shim 0.45 mm thicker. So these two valves are already adjusted, or rather the valve and the injector, and these are also adjusted, the valve and the injector. Next I turn the engine clockwise to the next mark, and we see there I have number 6, so I should, when this number, the 6th line, comes out here between these two lines, then I can adjust the valves of the 6th cylinder, or rather the intake valve of the 6th cylinder and the injector of the 6th cylinder. Well, now using these two as an example, using the 6th cylinder as an example, I'll show you how the adjustment is done. First, we turn it and align the marks. First, adjust the injector on the 6th cylinder. For this, we need to loosen the adjustment screw, unscrew the lock nut and tighten it. Here it stops, so we feel it moves easily, and then suddenly there's resistance. After reaching this point, we turn it 180 degrees. Well, just a little more. There the preload is set, we have the injector ready. Now we just lock it in place and the injector is done. It's adjusted. And as for the valve, basically nothing complicated there either. We unscrew it. The lock nut. We take a 0.2 mm filler gauge, insert it between this bridge and the pad, tighten it. There, it's tightened. Also, loosen it a little so that the feeler gauge moves with a slight effort. That's it, and we lock in place. That's it, the valve and injector are adjusted. Next, I turn the engine to the next mark. That will be V4. So, the exhaust valve on the 4th cylinder. I've turned it to the next mark. At this mark we can adjust the exhaust valve on the 4th cylinder. So we notice this gap. I've picked feeler gauges 0.85 plus 0.65, that's 1.5, and another 0.55, so that's 2.05. It's a bit tight, but basically it's fine. We see 2.05, it's tight, but it goes through. It turns out we are right, 205, but we should have 1/6, so that's a plus. 0.45. I don't know, I'll check now which shims I have on all the valves. That is, not a single valve has gone without adjustment yet. I mean, I thought maybe it would turn out that I wouldn't need to adjust them. We can see that all the valves need adjustment. All the valves need thicker shims. So, I'll see if I can at least do half of the valves using the shims I already have picked them out. And for the other half of the valves, we'll place an order, so we know exactly what sizes we need. We'll place the order, and then we'll have to wait for the shims to arrive. Next, I turn it to the next mark. There we have number 2, which means on the 2nd cylinder, I adjust the injector and the intake valve again, and so on. So next I'll start assembling the compressor. About the compressor. So I took it apart, checked what was needed, he cleaned it up. As you can see, the cylinders here are non-removable, each. There are some small scratches and longitudinal scuffs on the cylinders. I think they'll still work. The scratches aren't critical, well, because otherwise you either have to buy a new compressor assembly or just put it back together as it is. So what do we need to replace? We're going to replace the repair kit, obviously, all the gaskets, valves, and so on. And we're also replacing the pistons, meaning the kit comes with the rings. So you get a piston like this, piston wrist pin, circlip, and piston rings. Basically everything else stays the same. The crankshaft, connecting rods, timing gear, everything. So right now I'm working on repairing the compressor. I'll be assembling the compressor without filming it because I just want to get it done faster. It's already taking too long and the customer is in a hurry too. The next one will be here soon. There's another car in line. So I'm assembling the compressor. Next I still need to replace the pump. And I also need to clean the air manifold. Over there I still have a pile of dirty parts. The air manifold, the cover for the heat exchanger. And on the table there's a bunch of different pipes. Basically, there's still a lot of cleaning and a lot of work left to do. I don't know. It seemed like I was about to finish everything soon, but I think I'll be working on all this for another week. So, they brought me the intermediate gear and the shaft. I've already installed and tightened it. I also adjusted this gear again. Unscrewed 2 bolts at a time. Put them on thread locker, well in pairs basically, so it wouldn't shift. Put them on thread locker, tighten them, and also check the tightness of this gear. So now I want to show that the oil pump, we can see there's some play. Next is the intermediate gear of the oil pump. There's some play. This is the intermediate gear. There's also some play. This is okay. Now this one I just adjusted. So I cut the old probe so I could insert it so that, so look, if I insert it here, it goes in a bit, well, a bit tightly. We see there's no play here now, but we still have play here and in this spot. Not sure if you can see it on camera, but my timing gaps are good. I double checked everything. Now I'll line up the marks on the flywheel again. Open the inspection window and check the camshaft here. I'll look once more to see where the mark lines up. So, as for the valves, I've already adjusted 3 of them. Today a 2.65 plate arrived, so I installed the 2.65 and the 2.15. I ended up with a gap of 0.48. Well, not this valve right now. I adjusted this one last time, and I also had adjusted this one last time. So I still need 3 more plates. I'll have to wait a couple more days. They ordered about 10 pieces at once. Out of those 10, I'll pick the right sizes and we'll just return the rest. Alright then, so what should I do now? Now I'm closing this front cover, or rather, first I'm installing this counterweight on the crankshaft. Actually, not the counterweight first. First, I install the hub. On the crankshaft, I heat it up. Install the hub, then I attach this counterweight. I screw in this central bolt here, which holds the hub in place. I close this front cover. And then, I guess I close it up. There's also another small cover here. I also checked online how to install it, because it goes on with a rubber gasket. Basically, there are these oval holes there. You need to screw it into the oval holes, then tighten it on one side and align it with the head. Well, I mean, basically there are some nuances to it as well. We'll get to that in a moment. So, today I want to install the hub, the counterweight, close this front cover and close the oil pan, and maybe even put the engine in its working position. I installed the oil pan, did it off camera. Last night I got a bit frustrated with this oil pan, so I decided not to film that part. I made a decision. Leave out all the details. I'll just say one thing, Illumimi. The gasket here is very inconvenient. The installation system is very inconvenient, specifically the gasket. And then these aluminum rails are installed on top of the gasket. Well, I don't know who came up with this, who created this miracle. This is the first time I've seen something like this, and I never want to see it again. Alright, the oil pan is already installed. Next, I'll go ahead and install the front cross member, or whatever you want to call it. Basically, the mount where the engine attaches to the cushion. I'll put the plug here, I'll clean it now, and then install the pump. Well, basically, I'm starting to install some of the attachments here. And I've also received the plates for adjusting the valves. I'll close the air manifold first, then adjust the valves. I'm assembling as I go. Now I'll see what exactly I should work on next. So next I'm closing the upper front cover. I washed it, cleaned it and blew it out. So I replaced the gasket here. This is the kind of gasket we use, it's rubber. And what's special about installing this cover? What happens is we need to align this upper part with the head so that the valve cover fits. And we need to somehow press and squeeze this gasket. So we turn the cover over. We see that we have two oval holes. 1, 2. So we put the cover on these two bolts. We nearly tighten it, then use pry bars on both sides to press it in and align it with the head level. So that's the feature. Well, what can I say? This is what it's called. The engine is definitely interesting, with many solutions I've never encountered in my experience. There are plenty of intriguing and also very deep solutions here. For example, the oil pan mounting uses the same rubber gaskets and so on. I worked for a while without the camera. I'll briefly explain what was done. So I installed the intake manifold. I decided to install all the wiring right away. I installed the control unit and laid out the wires. I wrapped the injector wiring with electrical tape because the insulation was damaged and wires were exposed. I connected everything and tightened it all up. I also adjusted the valves already. Here you can see how it turned out. I indicated which ones, and the thickness of the shims. The shims are 4.6, 4.8, 4.75, and 4.7. But for some reason the second cylinder is 5.25 and the first is 4.8. I checked the valve adjustment again. That is, I turned the engine according to the marks, checked the intake and exhaust. So everything with the valves is also finished. I can put on the valve cover. I just need to screw in the studs for the valve cover here, and that's basically it. The valve cover is already ready as well. I washed it more than once, probably even more than a dozen times. I also installed the power steering pump, installed the fuel pump, laid out the fuel hoses here, and installed the filter housing. I've basically assembled this side. I still need to install the temperature sensor here. Basically, it's broken. For now, I've just put it in loosely. I'll be painting, and then after painting, the sensor will probably arrive. I'll have to remove this cover here, take out the jumper there, and install the temperature sensor, but it shouldn't take long. So now I'm putting the engine in its working position. Well, I'll probably close the valve cover and start assembling from that side. On that side, I still need to install the heat exchanger, close the cover, the compressor is thereafter, repair, and the pump. Continuing on, the turbocharger is already prepared after the repair. And the manifolds are also painted, and the manifold bolts are ready as well. Well, in general, there's still a lot of work to do. If you look at the shelves, all of them are still occupied with something. All of them. So I finished assembling the engine without the camera. In general, I installed everything. Even the filters are already installed. The gear shifter is installed. The valve cover is on and the oil filler cap is closed. Here is the breather. Here I installed the compressor. I showed the compressor after the repair, what was done and replaced. I installed the pump, and the pump itself is new. This part here is the one that gets replaced. So with the bearing and the impeller, this housing remains old. I also installed the filter. This is the fuel filter. By the way, this is the first engine where I've seen 3 fuel filters installed. And I also installed this valve on the engine brake. Basically, I didn't do anything else with the engine brake. Well, it's just because I physically didn't have time. At first, the customer didn't mention that it was hissing there. Basically, I need to check something somewhere. Maybe it's this valve, maybe it's the damper itself. Yeah, well. When the customer finally told me, I just didn't have time to do everything because they were already rushing me faster and faster. But the amount of work that's been done, you just can't do it any faster than I can. So that's how it is. That's why we didn't do anything with the engine brake. Everything stayed the same as before. So what's my task now? Now I'm going to prepare the engine for painting. As usual, I seal things here wherever there are technological openings, like here and here. So I seal it up, paint the engine and wait for it to dry. And today I definitely need to install the air manifold. It's already over there. Actually, the exhaust manifold together with the turbocharger is already prepared on the shelf. I already showed that I installed the turbocharger. The turbocharger has been repaired, and I've already painted everything with heat resistant and special paint. So today I definitely need to install the manifold after painting. I also need to install the new hydraulic clutch, which I'll show later. I replaced the hydraulic clutch there. I also need to install the belts, because once the hydraulic clutch with the fan is installed, there's no way to replace the belts. I'm not sure. It might be possible, but it would be difficult. So today I also need to put it on the oil pan, because tomorrow morning it will already be installed in the car. And the person who's doing the installation is probably planning to work with this engine all night. So basically we only have a few days left to finish assembling it, so to speak. Also, the gearbox will be installed separately. First the engine will be installed in the car, and then the gearbox will be installed. That's it, so there won't be a lot of filming right now. I'll quickly paint it and get it ready, then everything proceeds as I said. Alright, so my engine is ready. I installed the turbine and manifold, but some things remain, like the unpainted compressor air intake. I put all the little things in place, but forgot this plate, so I struggled and had to unscrew bolts. I installed a new hydraulic clutch, added protection, tightened everything, and got the engine ready. I also put on new belts. The customer asked to remove the air conditioner, so we put on a shorter belt, just from the pulley to the alternator. I tightened it here, everything's fine. Installed a new tensioner pulley and put this belt on the hydraulic clutch. As I said, we won't have an air conditioner here. Now, the engine repair cost will show up in subtitles. If I remember, I'll specify it. There you go. And basically, I'll be wrapping up the video about repairing this engine. Next, we might have, or at least we should have, some footages of starting this engine already installed in the car. I'll try to film, or at the very least, I'll try to capture the engine in working condition when it's installed in the car and when it's started to show how it runs. That's it. I'll end the video here. Thanks for watching. Good luck and goodbye. To be continued. Continued. So, the engine has warmed up. We see the oil temperature is 81 degrees and the pressure is showing well less than 4. That's somewhere around 3. It's hard to tell. Yeah, we don't have a scale here, but basically it's about 3. That's at idle, so we see idle at 550 revolutions per minute, and the needle is somewhere around 3.